Good morning. Today's lesson is all about low-level and high-level programming languages. So it's a nice crossover between the CT aspect and the P aspect. Remember, P aspect is mostly paper 1, the principles of computer science, topic 2, 3, 4, and 5. And the CT is computational thinking, and it's topics 1 and 6. So this is about low-level programming languages and high-level programming languages. So we want to know what both of those mean. There's some common misconceptions. Some people think that low level is like Scratch, it's easy, it's for beginners, and high level is for pros, and that's not the case. It's more about the levels of abstraction, and we'll come back to that later. Low level, think of an ant crawling around at a low level to the floor. And then high level, think about an eagle soaring at a high level above the ground. That's the kind of metaphor that we're thinking about here. An ant, if they see like a sandwich on the floor, that sandwich looks huge. You've got to walk all the way around it. You're obsessed by all of the detail if you're at a low level. If you're at a high level, you can see skyscrapers and cars and cities. You're not interested in the tiny detail if you're at high level. You can move very quickly and get a lot done and get to faraway places at a high level, whereas you've got to put a lot of effort in to get anywhere if you're at a low level. That's what we're talking about here. Low level means you have complete control over every resource that the computer has. You can make the processor do anything. You can control exactly what the processor does, but you've got to write a lot of code to do it. High level is a high level of abstraction. Remember, abstraction means hiding unnecessary something to focus on the most important something. I'll pause the video and you'll fill in the gaps. Hiding unnecessary details to focus on the most important thing. So a high-level language has a high level of abstraction. That means we're hiding a lot of unnecessary details to focus on the most important thing. What details are we hiding? Well, we'll see this lesson what we mean. We're hiding how to allocate memory. We're hiding exactly what instructions the processor is doing. We're hiding like having to free up memory afterwards. To focus on the most important thing, what do we mean? Well, what the user wants and what the programmer wants, as in your procedures, your functions, things like displaying text to the screen. That's what we care about. We don't care about allocating the memory and freeing up the memory afterwards. If high level lets us write less amount of code to do more, why on earth do people still write low-level programming languages? That's something we'll come back to in these slides, hopefully, but you be thinking about it. We need to explain why a processor has a unique instruction set and what an instruction set is. We need to understand what the differences are between something where you write a lot of code to do very little, but it runs it very quickly, and where you can write a little amount of code to do an awful lot, but it might be bloated and use more memory than a low-level language. And we need to work out not the fact that one is better than the other, but they are both good, but for different tasks. Okay. So first of all, an instruction set. Every CPU has a limited instruction set. Think like add, subtract, multiply, divide, display a pixel, things like that. All of these instructions are represented like anything else as binary. And then the CPU's job, there's no magic involved. All it does is it goes off and fetches an instruction from memory. It understands that instruction, and then it executes, it runs that instruction, and it does that over and over again. We call it the fetch, decode, execute cycle because it happens over and over again. The actual instructions, those binary patterns, we call them machine code. Very few people will look at the binary and say, oh, I recognize what this program does, but you can. The computer, the CPU, only understands the machine code. The code that you're most used to recognizing is in Python, but the CPU doesn't understand Python. In order for it to be run on the CPU, the Python has to be interpreted into machine code first. So the machine code is as close to the ground as possible. Think of that ant that we talked about. It's as close to the ground as possible. Machine code is low level. It has complete control over what the CPU does. And it's quite challenging for humans to understand. So this could be a picture, or it could be a number, or it could be machine code. The CPU, if it's told to execute it, will try and execute it. We don't understand what it is, but we could if we looked up the details for a specific processor. Assembly code is one step of abstraction away, one step of hiding unnecessary detail. We're hiding the individual zeros and ones, and we're saying, right, something that doesn't look particularly easy to understand, but we're moving the value 12 into this register. We're moving the value 8 into this register. We're adding what's stored in this register and that register, and we're storing the result in here. So you can just about work out what it does. We call these mnemonics. It's kind of short for something. You don't need to remember these mnemonics. You do need to remember the fact that assembly code is low-level code. Why is it low-level code? Because you've got complete control over what the processor does. In Python, is there an example in Python here? I hope so. If we were to write this in Python, it would just be 12 plus 8, or answer equals 12 plus 8. High level is easier to understand, but low level gives you complete control over the timing, the speed, and the memory allocation. So I'll pause the video and we'll discuss when would you use low level code and when would you use high level code. So we've said that low level is ideal for things that we need performance for, like a graphics card driver. If you're playing a game that only has, 3 frames per second and it's really juddery, it might be because your graphics card driver is written in a high-level programming language like Python, which is easy to write for the developer but incredibly slow to run. If you can rewrite that code in a low-level language like assembler, you could maybe get your frame rate up to 60 frames per second on the same hardware, because you've got complete control over every aspect of the hardware. So, our definitions. Low level does not mean easy. Please don't make that mistake. Low level is probably harder for the programmer to understand, but it's low level because it's a low level of abstraction. It sits very low down, close to the computer hardware. So, drivers of any sort that communicate with your hardware is low level. It can be assembly. Remember, that's like mnemonics. Or it can be machine code. That's the binary. And these mnemonics are things like add, sub, things like that. High level then is not hard. It's actually easier for the programmer to understand. It's a high level of abstraction, a high level of removing unnecessary detail. It sits a long way away from the hardware. So in order to talk to the hardware, you're probably going to have to speak to the drivers, which are written in the low-level code. You can write a short amount of stuff to do a lot. You don't care about how your print or your input function works in Python. You just know that it does. But that print and that input will have to be interpreted into machine code, which will be at some point written in a low-level programming language. Python is written in C. C is a low-level programming language and a high-level programming language if you want it to be. So you don't write things like mov and add and sub. You write things like input and print. But you need a translator to go from Python into your machine code. Or you need a compiler to go from C# into your machine code. So a translator could be an interpreter or a compiler. So these are some examples. Everything that you've done is a high-level programming language. So C is a high-level programming language. This is Java. I haven't taught you Java, but I'll pause. Have a think what you think it does. We've never seen Java before, but we know enough to recognize we've got a variable here that stores an integer to do with time, maybe. And based on the time of the day, it will, well, this is like print in Python, isn't it? It's a bit more complicated. You have these nasty semicolons at the end, but you can just about understand what it does. You don't need to understand Java for any exam in your Edexcel GCSE Computer Science. Here we go. Every processor has its unique instruction set. If you've got an AMD processor, it will have a slightly different instruction set to an Intel processor. If you have an ARM processor on your phone, it has a very different instruction set. The instruction set is what you understand. So the architecture means you've got a certain limit of what you can do. So the instruction set is how you control it. For example, this is an instruction, and it tells you to move the value 12 into this register. So different CPUs might have different registers. Some might just have one, some might have loads. Hi, sir. So every processor has a different instruction set, which is a problem. If you're writing code that should run on every single processor, you're going to have to write different code for every type of processor if you write it low level. But if you write it in Python, a high-level programming language, it will then run on any computer because it can be interpreted into the correct machine code for that particular platform. We call that cross-platform code. It's an advantage of high-level language. Write it once, run it anywhere. So this is the most important thing. I won't go through it because you've got access to the PowerPoint and you can use it for the Word document as you go through. Your job today is to find the P9 worksheet. You've got an example of C here, which looks kind of human readable. So therefore, it is a high-level programming language. Okay, so we're in half term 8. We're in P9, and I'll give you your screens back. So on the first activity, you've got some code in C. If you want to learn C, you can teach yourself. There's loads of good resources. It's probably one of the harder languages to learn because it's both high level and low level. You can make a lot of very fast programs. Python itself is written in C. Some university courses teach you C in the first year. So Cambridge particularly is a big fan of C because it gives you the high level stuff. You can write a little to do a lot, but it doesn't hide all of the unnecessary stuff that Python hides away from you, like memory management. So it is a good language, but it's completely beyond the scope of GCSE. So if we recognize stuff, there's something that looks a bit like output. C out, console output is what this means. We're outputting I. What is I? Well, it looks like a variable that's initialized to store 0. And then we've got a while loop, bit similar to Python, but we use these curly brackets. One of my ex-students called them mustache brackets, which I rather like. So it doesn't rely on indentation like Python does, but we still use indentation. It's basically saying output whatever I is and a \n. Some of you have asked what that means. It's just a new line. In Python, whenever you do print, it automatically puts it onto a new line. It doesn't automatically do that in C, so the \n will put it onto a new line itself. So this is just going to say 0, 1, 2, 3, 4, and then it won't show 5. Or will it? While I is less than 5, no, it won't. It will stop at 4, I think. This one is a low-level programming language. How do we know? Because of those mnemonics that we've seen in the PowerPoint. You have to write a huge amount more to be able to do the same thing. Each mnemonic ends up being one location in memory. It assembles into, well, if you've got a 32-bit processor, it's going to be 32 bits of machine code. So you've got complete control over the order that everything happens. So if it's timing critical, you can get the processor to do exactly what you want. That's more detail than you need for GCSE. At the moment, you just need to say that this is a low-level language because it's less human readable. It uses mnemonics instead of human-like language. So when you've finished your worksheet, and I've recommended to the class that activity 2 is optional. You can do it. That's what you need to do to get the excellent for this one. But I think it's beyond what you need to understand for the GCSE. So save this into your topic 5 folder and then upload that P9 worksheet into half-term 8 issues and impact 2. I'd recommend, if you have any time left, after completing activity 1, you should have a look at page 44 of your revision guide and then have a go at page 44 of your revision workbook. I think that's a really good way to consolidate this into you knowing exactly what you need to know for the GCSE.